Hi guys, greetings from CALQ. Today I'm going to show you how to design a doubly reinforced beam using CALQ RCBM. Okay, so we have here our app and we have here the reference manual of CALQ RCBM. So if we open this interactive reference manual and look for the table of contents, so we have here, so dito lang ako sa may example, no? So, dito sa doubly reinforced beam, and so, dito ako sa chapter 5, and sabihin natin, basahin natin ito. Okay, so, yan na. And, yan, so, solve natin yung problem na to using CALQ RCBM. So, dito sa reference manual, I have also included the conventional solution, no, as a verification na din, no, for CALQ RCBM. So, I solved this problem step by step, and also I have also included the computation using the CALQ RCBM, no, which is almost the same, no? So anyway, dito tayo. So a rectangular concrete beam having a width of 300 mm and effective depth of 500 mm for tension bars. So if required, compression bars will be located at D prime, which is equal to 65 mm from the topmost fiber of the concrete beam. So assume FC prime is 27.5 megapascal and Fy is 415 megapascal. So use 2010 or 2015 na NSAP code provision. So determine the area of tension bars if the maximum applied moment is 592 kilonewton meter, and also determine the area of the compression bars needed if the maximum applied moment is 592 kilonewton meter. So, bali dito sa problem, given yung dimension and also yung mga material properties, and also given yung demand, no? So, we have the demand, which is the maximum applied moment na 592. So, ngayon, solve natin yung problem na to using the CALQ RCBM. So, let's open first the app. And then, click lang natin yung login. Okay, so, dito na tayo sa working space ng CALQ RCBM. So, since yung problem is a design problem, no? Kasi yung tinatanong is ano yung cross-sectional area, no, ng mga rebars. So, let's go here, getting started, and click the design process. So, dito sa design process, actually pwede tayo i-click muna natin to kung maka-add tayo ng dimension. Actually, meron itong load example, no? So, click on others. So, nandito yan, no? Para ma-test out mo lagi, no? So, in this case, I'm going to start from scratch. So, here, in beam width natin, that is given, we have a 300. And then, yung effective depth in tension, we have 500. And then, yung sa compression, we have 65 na. So, dito yan. And then, actually, yung ito, meaning hindi siya kasali sa by default, dito sa CALQ RCBM, hindi talaga ito kasali. Yes, bro. Anyway, click on this one and add. Assume ko na lang na 40, no? So, anyway, if you click on this one, input the concrete cover of the beam in millimeter according to the CP. The minimum concrete cover for beam is 40 mm. So, Click lang natin to. And then here, sa materials, we have FC prime that is also given 27.5. Click lang natin. And then here's FY. We have 415. So, yung stress dito. So anyway, maglalagay lang din ako ito ng 23.5. Though hindi naman to kasali talaga sa calculation, no? By default dito sa CALQ RCBM. So now we can now calculate the beta factor in accordance with 2015 na NECP. So if you click on this one, makikita natin na 0.85, no? So which is correct kasi pag 2001 NECP, that is if less than 30 megapascal. Pag 2015 and 2010, that is pag less than siya ng 28 megapascal. In this case, yung FC prime natin is less than 28. So that's why beta is 0.85 and let's click save. So next is yung next is yung rebars, no? So yung bottom bars di niya binigay. So mag-assume na lang tayo dito, no? So in this case, I add 20 and dito naman I add 12. Kasi yung concern natin dito is yung area naman, no? So pero kung maglalagay ka nito, meaning you want the CALQ RCBM to compute for the number of rebars. Okay. So dito naman, yung given na demand, we have the maximum applied moment which is 592 kilonewton meter. So yan yung ilalagay natin dito. 592 kilonewton meter. And then we click on save. Okay, so now we are ready to analyze the So we can now click on run analysis. And so again, gagamitin ko yung 3/7, no? Kasi sabi sa NECP, at least, no? Hindi kang gumamit ng 0.004. So anyway, transition zone, recommended. I'll just click on recommended. And then let's wait for the CALQ RCBM to calculate. So yung kinaganda ng CALQ RCBM is makikita mo yung step-by-step na computation nila. So let's skip this one sa 2001. I'll just indent that para makita mo agad yung difference ng 2001 at 2015. So makikita natin dito na yung MU max is 482.22. But if we'll be using the 2015 NECP code, so gamit yung 3/7 times D for C. So makikita natin na 425. Diba? Makikita mo yung difference na 425.44 and we have 482. Anyway, bottom line, yung remarks is again, doubly yung, yung beam natin. Ha? So, if we check here in our conventional computation, so if we click on this one, and let's check. So, yung MU maximum na nakuha natin is 425.69. No? So, anyway, I think due to decimal, no? So, anyway, sobrang lapit man din nila, no? 425.44. So, anyway, we have a doubly reinforced beam. So, ngayon, we can now proceed to the design, no? Click on proceed. And since doubly, so we click on doubly. And then, calculate. Ayan, so, ngayon, kukomputin mo na ito. So we have this design calculation. Ayan. And then we have 2001. So sinali ko pala yung 2001. So ito yung concern natin, yung 2015 na NECP. Okay? So we have 3/7 times the D. We have 214. And yung A natin is 182.143 na. So, yung nakuha natin na fee is 0.8145. So, yung MU1 is 425.44. So, we have ES1, MU2 exists. So, we have now ito no, yung area of the tension force. So, may kita natin na 4210.5, no? So, kung titignan natin yan sa conventional, so, makikita natin dito na we have 4208.18. So, I guess due to decimal. So pareho lang, ha? So, check if yung compression still yields or not. So, ganun din dito, no? So, makita natin na yung compression steel yields, so we have this cross-sectional area for compression bars na 132.73. So, sa conventional, maybe I guess due to decimal, so we have 130.4. So yan lang, ha? And how to perform the design process for doubly reinforcement using the CALQ RCBM. Okay, so that's it. So, thank you for listening and keep safe, everyone.